Hello everyone. Today we are going to discuss about the properties of salt. In last class we discussed about the salt and the types of salt. We discussed about what are salt. Okay, salt is nothing but the compound which are formed by reaction between acid and base. Okay, the compound which is formed during the neutralization reaction along with water is called as the salt. And we discuss about like various chemical reaction in order to understand how salts are formed. And then we discuss about the types of salt in which we gone through about the strong acid is reacts with the weak base, so the salt will be acidic in nature. If strong base reacts with weak acid, so it gives the basic salt. Or if strong acid reacts with strong base or weak acid reacts with weak base, they form neutral salt. We already covered that in last class. So today we will cover about the properties of salt. Okay. So first property. See, generally, salt are formed by the reaction between metal and a non-metal. Just to remember, very important. Okay, generally salts are formed when metals reacts with non-metals. Okay, so salt generally they formed by positively charged metal ion and negatively charged non-metal ion. Positively charged metal ion and negatively charged non-metal ions. Okay, okay. So there is a like charge. The charge on the opposite, ion is opposite. Like one is having positive and other is having negative. So these are called as beta ions. These are called as ions. And the see positive charge metal ion and negatively charged non-metal ion. Okay. So due to opposite charge, they have very strong force of attraction between them. They have very strong force of attraction, and that strong force of attraction is called as electrostatic force of attraction. It is called as electrostatic force of attraction. And that strong force of attraction working between two ions, that positive ion is called as cation and negative ion is called as anion. So cation and anion are oppositely charged. That's why they attract strongly to each other. Hence, in order to break that particular bond, okay, require very like more amount of energy. That's why melting point and boiling point of ionic compound are, or we can say salt, is very high. Is very high. So let's discuss from the notes now. Melting and boiling point first we are going to discuss. This is our first point to discuss. Okay. Salts are the mostly solid. Okay, they are solid because they are bonded with other molecule with very strong force of attraction, which melts as well as boil. So that's why if it is they are solid, so it will melt, and on further heating they will boil at a very high temperature. So why they require like very high temperature? Because they are bonded with strong electrostatic force of attraction. This is the reason for that. Second property. So just do remember first property, melting point and boiling point of the salt is very high. Second, solubility in water. See, as we discussed already, salts are formed by positive and negatively charged species. Okay, and water molecules. See, water molecule also have like positive charge on hydrogen and slightly negative charge on oxygen. So slightly positive charge and slightly negative. So opposite charge are formed. That's why they are called a bit of polar compound. They are called as polar. Why polar? Because positive and negative to opposite charge or pole are formed. That's why they are called as polar compound. So salts are also polar because they contain positive and negative ion in it. That's why salts are also polar. And we have one like golden rule for solubility. Golden rule for solubility. And what is it? Like dissolve in like. If salts are polar, so they are going to dissolve in polar solvent only. So water is also polar, so it is going to soluble in water. So see here, salts are generally soluble in water. So what is the reason? Because water is also polar compound. Polar means what? Positive and negative charge acquire in that. And salts are also polar because they are found by positive and negative ion. Okay, that's why. Example: sodium chloride will dissolve in water, potassium sulfate, aluminum nitrate, then we have ammonium carbonate. Okay, all these are soluble in water. Okay, are soluble salt, while silver chloride, lead chloride, copper carbonate, etc. are insoluble. So see, do remember these are the insoluble in water, which are silver chloride, like lead chloride, copper carbonate, etc. These are insoluble in water. They can soluble only at a very high temperature, otherwise they don't dissolve. Okay, now third property of salt is water of crystallization. Very important. See, if you will observe that copper sulfate, it is blue in color. It is right in front of your screen. It appears blue in color. Blue. Okay, but if you will heat that, suppose here I am just performing one experiment so that you can understand. Suppose here we have one bowl. Okay, that dish contain copper sulfate. It contain what? CuSO4. And if we will, and how it appears? Blue in color. Blue in color. If we will heat that, if we will heat that, that blue copper sulfur contain water molecule will evaporate. H2O molecule, H2O molecule will remove out, and only like dehydrated copper sulfate will present here. Dehydrated CuSO4 will appear, will present only. See that copper sulfate which is blue, so it is hydrated one, means it contain water molecule. It appears blue in color, that's why it is called as blue vitriol. It is called as blue vitriol. Okay, but if you will heat that at a high temperature, water molecule will get evaporated and only like dry, or you can say dry or dehydrated copper sulfate will remain there. So it appears like it loses its blue color. Okay, it loses its blue color, and it appears like white powder or crystalline white. Okay, that means that blue color is due to that water molecule present in crystalline structure of salt. Okay, so that water molecule present in crystalline structure of salts is called as water of crystallization. Understood everyone? Okay, see, generally salts are found as a crystal with water molecules. So whatever the salt we have, okay, they are known to human being. They contain water of crystallization. They contain water of crystallization, means water molecules are present in their crystalline structure. Okay, this water is called as water of crystallization, and such salt are called as hydrated salt. See, they are called as beta hydrated salt. So in copper sulfate, if it is blue in color, so as you can see here, copper sulfate plus 5H2, that dot 5H2, that means in blue copper sulfate, 5 molecules of H2 water molecule are present. Hence, it is called as hydrated salt. It is called as hydrated salt. Okay, if you will heat that, so that 5 water molecule will get evaporated, so it is called as then dehydrated salt. It is called as dehydrated, and that water molecule present in crystalline structure of copper sulfate, due to which that copper sulfate appears blue in color, so that's why it is called as beta blue vitriol. Okay, one more example we have, that water molecule is called as water of crystallization. Water of crystallization. One more example we have, which is for ferrous sulfate. FeSO4. FeSO4 contain 10 H2O molecule. 10 H2O. Okay, and it appears green in color. Green. Ferrous sulfate appears green in color. Hence, it is called as green vitriol. It is called as green vitriol. Okay, so blue vitriol and green vitriol. Okay, So now I want you have to like ask question. Wait a second. Now we are going to discuss about the uses of salts. Uses of salts. Okay. So here we have some examples of the salt along with their uses. So first we have calcium carbonate. Okay, where it is present generally in marble, in limestone, and chalk. Okay, and its formula is CaCO3. It is calcium carbonate, which is nothing but the salt. So where it is used? It is used in flooring in front of the marble. Okay, for like flooring, we are using that in the form of marble. We are using in flooring to make the lime. You know that calcium oxide we used to make by using calcium carbonate. So what we used to do? Calcium carbonate used to heat it at a very high temperature, and it gives CaO along with carbon dioxide. Okay, so this is called as lime. Okay, in cement factory we are using calcium carbonate, and for extraction of iron. So in extraction of iron we are using calcium carbonate. Second, we are going to understand about the sodium carbonate, which is used in washing soda. Okay, and its molecular formula is Na2CO3, and here we have 10 water of crystallization. So do remember that if it is given here, means it is important. So question may be asked like how many water molecules are present in crystalline structure of sodium carbonate? So your answer must be 10 water molecules. Okay, where it has been used in cleaning, in detergent, for for water softening, for softening the water we are using calcium carbonate, and in the manufacturing of glass. Okay, glass manufacturers they use calcium carbonate, sodium carbonate. Third use, third is for sodium bicarbonate. It is also called as baking soda. It is used in bakery and in medicine. Number 4, silver nitrate, where it is being used. So it is used in photography of the developing film. Okay, so in old days we are having the camera. They used to use that reels. Okay, here we have the reels, and that reels is like photosensitive. Okay, so that camera we have in old time. Here we have the shutter, and here we have the lens. So only like for few seconds, not few seconds, only fraction of second, the shutter used to open and light enters inside it. And when light enters, whatever the like image right in front of the lens get printed on that negative. We used to call that negative. Okay, and from negative, positive films are being formed. Again, here we used to use that silver nitrate solution. Okay, so it is used in photography for developing the films. Fifth, ammonium nitrate, NH4NO3. It is ammonium nitrate. It is used in fertilizer and explosive for making bombs and other explosives like firecrackers. Ammonium carbonate, ammonium nitrate is being used, and even in fertilizer. Sixth use, potash alum. Okay, it is also called as fitkery. It is potassium sulfate, aluminum sulfate, and 24 H2O. So do remember that potash alum or the fitkery contain 24 water of crystallization, and it is used in purification of water. It is used in purification of water. Last but not the least, sodium chloride, common salt, NaCl. Okay, it is used generally in our daily diet in kitchen. Salt as as seasoning of the food in manufacturing of the chlorine and sodium carbonate. For preparation of sodium carbonate, we are using sodium chloride. For chlorine gas, preparation of chlorine gas, we are using sodium chloride. And sensing in the food means for like providing salty flavor, we are using sodium chloride. So these are the uses of salt. So I want everyone had to take a screenshot for that first. Now I am going to share you one video by which you can understand what are the effects of acid and base on natural indicators. So do observe the video carefully.
Zara and Zen were all excited to perform a series of tests on a few solutions to find out whether they're acidic or basic. Their teacher handed a few yellow-colored paper strips, and before she could return to guide them, Zen had already dropped a few drops of some solution on it. And to his surprise, the paper turned bright red. Both Zara and Zen were confused with this magic. How did the paper turn red? The teacher returned and explained that the two had performed one of the detector tests. They were supposed to detect whether the solutions given are acidic or basic. And since the yellow paper changed color and turned red, it indicated that one solution was tested. But how does this paper tell us the nature of the solution? Do you remember understanding the concept of indicators in the previous video? These are nothing but substances that help us detect whether the given solution is acidic or basic without having to taste it. So, is this yellow paper an indicator? Yes, it is. And what is this made up of? It's simply a blotting paper with turmeric applied to it. Turmeric? Yes, it is. The same turmeric that's used in the kitchen. Turmeric is an excellent indicator to detect the acidic or basic nature of the solutions. In this case, the paper turned red when the solution was poured onto it. So, what did the indicator tell us? It clearly indicated that the solution was basic. Yes, alkaline substances or solutions turn turmeric into a red color. More the basic nature, brighter the red color will be. And what about acids? Acids have no color change when tested with turmeric. The color of turmeric, which is yellow, remains unchanged. The solution remains unaffected. That is how turmeric helps differentiate between acids and bases. Acids remain unaffected while basic solutions turn red. And there are more natural substances that can be used as indicators. Yes, there are many in the list. Next, let's look at two more natural indicators which help in detecting the acidic and the alkaline nature of solutions.